Deploying a Kubernetes cluster for container orchestration involves several steps to set up, configure, and manage the Kubernetes environment efficiently. Kubernetes simplifies the deployment, scaling, and management of containerized applications. Here's a concise guide on how to deploy a Kubernetes cluster. Steps to deploy a Kubernetes cluster. 1. Choose a deployment method. Cloud providers. Many cloud providers offer managed Kubernetes services, e.g., Amazon EKS, Google Kubernetes Engine, Azure Kubernetes Service. Choose a provider based on your preference, expertise, and integration needs. On-premises or self-managed. Deploy Kubernetes on your own infrastructure using tools like KubeM, Kubespray, or Rancher for on-premises or bare metal environments. 2. Set up infrastructure requirements. Nodes. Prepare at least 2 or more servers or virtual machines, nodes, that will serve as Kubernetes worker nodes. Ensure nodes meet hardware and operating system requirements specified by Kubernetes. Networking. Configure networking between nodes for communication. Each node must have a unique host name, and nodes should be able to communicate with each other over a private network. 3. Install container runtime. Docker. Kubernetes primarily supports Docker as the container runtime. Install Docker on all nodes to manage containers effectively. Containered. CRI-O. Alternatively, Kubernetes supports other container runtimes like Containered or CRI-O, depending on your deployment requirements. 4. Install and configure Kubernetes components. Install KubeM, Kubelet, and kubectl. Set up Kubernetes control plane components, KubeM, Kubelet, kubectl, on the master node and worker nodes. These components manage the Kubernetes cluster and facilitate communication between nodes. Initialize Kubernetes cluster. Use KubeM to initialize the Kubernetes control plane on the master node, which sets up essential components like API server, scheduler, and controller manager. Join worker nodes. Join worker nodes to the Kubernetes cluster by running the KubeM join command with the token generated during cluster initialization. 5. Configure networking and storage. Networking. Choose a network plugin, e.g., Calico, Flannel, Cilium, to enable networking between pods across the cluster. Configure networking according to the chosen plugin's requirements. Storage. Implement storage solutions such as Kubernetes Persistent Volumes, PV, and Persistent Volume Claims, PVC, to provide storage resources to applications running in Kubernetes pods. 6. Deploy applications and services. Create deployments. Use kubectl commands or YAML manifests to define Kubernetes deployments, which manage pods and ensure application scalability and fault tolerance. Expose services. Expose Kubernetes services internally or externally using kubectl expose commands or ingress controllers to enable external access to applications. 7. Monitor and manage the cluster. Monitoring. Implement monitoring and observability tools, e.g., Prometheus, Grafana, Kubernetes Dashboard, to monitor cluster health, resource utilization, and application performance. Logging. Configure centralized logging using tools like Elasticsearch, Fluentd, and Kibana, EFK Stack, or Loki to capture and analyze Kubernetes logs for troubleshooting and debugging. 8. Implement security best practices. Role-based access control, RBAC. Configure RBAC to enforce granular access control policies and restrict permissions based on user roles and responsibilities. Network policies. Implement network policies to control traffic flow between pods and enforce security rules to protect applications and sensitive data. 9. Implement continuous integration, continuous deployment, CI/CD. Integrate CI/CD pipelines. Set up CI/CD pipelines using tools like Jenkins, GitLab CI/CD, or Argo CD to automate application deployment, testing, and rollout updates to Kubernetes clusters. 10. Regular maintenance and updates. Patch and upgrade. Regularly update Kubernetes components, container runtimes, and plugins to patch security vulnerabilities and benefit from new features and improvements. Backup and disaster recovery. Implement backup and disaster recovery strategies to protect data and ensure business continuity in case of hardware failure or data loss. Deploying a Kubernetes cluster involves setting up infrastructure, installing Kubernetes components, configuring networking and storage, deploying applications, and implementing security and monitoring practices. Kubernetes provides a robust platform for container orchestration, enabling efficient management of containerized applications at scale. By following best practices and leveraging Kubernetes ecosystem tools, organizations can optimize resource utilization, enhance application scalability, and streamline DevOps processes for modern cloud-native applications.